I'm Ti-Chung from University of Illinois Urbana-Champaign, and I'll be presenting our paper, Organize Then Vote, Exploring Cognitive Load and Quadratic Survey Interfaces. Multi-option preference elicitation, although it sounds technical, is actually quite common. For example, national polls regularly ask citizens to rank policy issues, guiding government priorities. In HCI, we compare multiple interface design and gather user preference to make informed decisions, and everyday tasks like scheduling meetings rely on participants sharing preferences to reach a consensus. We rely on tools such as the Likert-scale survey, which is widely used to capture rating across option, or one person, one vote, where participants simply choose their most preferred option to elicit individual preferences. Quadratic surveys have emerged as a new alternative inspired by quadratic voting mechanism. This method is capable of eliciting both ranking and rating data across multiple options for an individual. How does it work? Let's take a look at an example. In Quadratic Survey, there are three key elements. We begin from the first one. Suppose Sam wanted to express their preference across a list of fruit options on a survey provided by the Weekend Fruit Fest organizers. The options were bananas, apples, and strawberries. The survey provided Sam with $20 to express their preferences. Suppose Sam dislikes bananas and really wants strawberries, they can add 3 downvotes to bananas and 2 upvotes to strawberries, like this. Since QS follows a quadratic cost structure, that would be $9 for 3 downvotes and 4 for 2 upvotes. In other words, each additional vote costs more than the last, and Sam needs to make sure the total cost stays within budget. Now, not only did Sam express their preference, the entire group did so, and so by aggregating everyone's vote, we could identify the group preference. In this case, strawberry received the highest vote where bananas were the least preferred by the crowd. This is how QS works. Prior studies showed QS better reflects participant preferences when compared to traditional Likert surveys in 3 ways. First, QS results show fewer extreme outcomes. Second, QS response aligned more closely with participant actual behavior. And lastly, QS provide richer data that better informs decision making. While QS can be beneficial to researchers, survey participants can feel QS challenging to complete. One notable QS challenge relates to cognitive demand. Existing literature highlights preference construction as inherently demanding, and this difficulty intensifies when participants face numerous options as seen in real-world quadratic voting setup, which closely relates to QS. Research also shows that participants experience choice overload tend to provide satisfactory rather than optimal responses. Given that QS introduces additional complexity through quadratic cost and vote management, this high cognitive load may impact the effectiveness of QS outcome. In addition, prior world events have demonstrated the consequences of poorly designed preference elicitation interfaces, such as the Battle of 5 Bullet and ill-designed arrow ballots, which researchers believe both impacted election outcomes. Prior HCI research has also shown how survey interfaces such as ordering and placement of survey options affect responses. Current QS-like interfaces rarely consider respondents challenging, and most interfaces remain similar, emphasizing only mechanical survey operations, such as presenting a single list of options, the vote controls for the options, the summary statements, and the current status of the overall question. They overlook possible challenges respondents face when completing quadratic surveys, and thus we ask in the study, how can we design interfaces to support participants in completing QS more effectively? By effective, we focus on reducing respondents' cognitive load in quadratic surveys. Specifically, we examined how the number of options in our proposed two-phase interface influence participant cognitive load. We also explored the sources of cognitive load participant experience when completing QS and observed whether participant behaviors differ between interface versions. Grounded in preference construction theories such as differentiation and consolidation theory, we propose a two-phase interface design. In the first phase, participants organize their thoughts if they choose to do so. Options appear one at a time, and participants categorize them into 4 groups. After selection, options reposition themselves according to their assigned group. When participants feel ready, they proceed by clicking to enter the voting phase. In the voting phase, the groups and the options within the groups retain relative position. So in the order of lean positive, lean neutral, lean negative, and the rest of the options. The mechanical part mirrors current QS interfaces, which we provided a dropdown for vote control that also shows vote tally and the corresponding prices, and then followed by a summary box showing the respondents' remaining credits. Participants can move between the two phases as they like. The control group used a text-based interface similar to existing QS design, and they match our proposed interface visually but differ in 2 ways. First, options were randomly ordered, and second, there's no two-phase organization process. To address our research question, we conducted an in-lab between subject study where participants complete a quadratic survey on societal issues. The short survey had 6 options with 59 credits, and the long survey had 24 with 470 credits. These choice of options and budgets were based on prior research. After completing the survey, participants filled out the NASA-TX and participated in a contextual interview. Key findings from NASA-TX results were surprising to us. Contrary to our hypotheses, cognitive load trends decrease as the number of options increase for participants using the text interface. Moreover, in the search survey case, the results aligned with our expectation. Participants using the two-phase interface experienced a trend toward lower cognitive load compared to those using the text interface. However, in the long survey, the results again contradict our hypotheses. Participants using the two-phase interface experienced a trend toward higher cognitive load compared to those using the text interface. Given these unexpected findings, we perform additional qualitative and quantitative analysis to further understand participant experiences and underlying factors. And here's what we found. To better understand these findings, we analyze our qualitative results through cognitive load theory. Cognitive load consists of three types: intrinsic load, which refers to understanding the question and the options; germane load, processing and evaluating preferences; extraneous load, navigating and operating the interface. Since all participants saw the same question and randomized option, we focus on germane and extraneous load. Qualitative data showed that twice as many participants using the text interface cited operational tasks as a source of cognitive demand compared to those using the two-phase interface. For example, participants would mention difficulties in operating to be within budget. Conversely, participants using the two-phase interface reported more sources contributing to germane load, particularly regarding strategic consideration and holistic evaluation, especially when dealing with numerous options. For example, this participant noted, with so many different societal issues, how do I personally prioritize them? This code underscores how participants engage in strategic evaluation across options more holistically. Altogether, the takeaway here is that we interpret the result as the two-phase interface shifted participant cognitive demand from focusing on operating the tool to being more engaged in constructing preferences across the options, especially in the long survey. Our behavioral data aligns with our qualitative finding, and one of the several analyses focus on edit distance per action, which measures how far participants move between options when adjusting votes. For example, if a participant added option 1 then jumped to option 6, the added distance would be +5, and in this other case, it's -3. We use this metric to track participant navigation through the interface while completing the survey. The scatter plot shows all edit made by all participants using a long text interface. The y-axes represent edit distance and the x-axes reflect the task progression. Each dot represents the number of participants who made an action at a specific step. Notice how scattered these dots are. Participants frequently move up and down, suggesting active searching and vote adjustments throughout the survey. Now look at the two-phase interface participants. They tend to edit options near their previous edit, indicating that the organization phase helped them make more localized adjustments. Additionally, participants spent more time per option in the long two-phase interface, and these behaviors supports our claim. The two-phase interface shifted participant cognitive focus from operational tasks to deeper engagement with survey options. We also identify instances of satisficing where participants settle for a satisfactory answer rather than optimizing their responses. This is evident in the two quotes shown here. Although we did not explicitly ask about satisficing, our analysis of survey respondents' approaches revealed that over half of the text interface users exhibit satisficing behaviors. In contrast, we observed fewer instances along the long two-phase participant and none among short two-phase participants. This suggests that the two-phase design may help reduce satisficing behavior. Let's summarize the key takeaways. First, we showed that a two-phase interface supports participant deeper engagement with options and potentially prevents satisficing behaviors. Second, QS does require high cognitive load, and thus we recommend using it in high-stakes settings with limiting number of options. And finally, our findings recommend providing QS respondents ample time for completion. Before wrapping up, I want to emphasize that quadratic surveys, although relatively new, are now ready for real-world use. Our research showed how interactive interfaces help participants construct and express preferences more effectively using QS, a tool that elicits rich preference data. We see great potential for QS in research, especially where careful preference construction is crucial. If you're interested in using quadratic surveys and think they fit your work, we love to collaborate, support, and guide you through adoption. To learn more, check out our full paper. Thank you, and this concludes our presentation. I'd like to thank my collaborators again and the Center for Just Infrastructure for partially funding this research.